All right, this is Unit 1, 1.1, Solving Equations, Day 1. So if we're following along in our assignment sheets, which apparently I moved here, we are looking at now moving from recalling notations and vocab to solving equations Day 1. This is, again, a review. We did this last year. We studied this in 8th grade and even beyond before that. So these are just going to kind of get our brains going as far as solving 1, 2, or multi-step equations. So the first thing we want to think about is, how do I move things across an equal sign? And we use what are called inverse operations. So these are the operations that undo another operation. And so when we're looking at this, we're thinking of more ones that are like adding and subtracting. These are inverse operations. When we look at multiply, and the inverse would be dividing. Those are operations that undo another one. Okay, what about squaring something? If I had x squared, how would I unsquare something? That's where we would bring in a square root. And to go along with that, we could have x cubed and a cube root. So these are the main ones that we're going to be using. Mainly when we start doing our inverse operations, we're going to be doing some of the basic ones. Solving an equation tells us that we want to get a variable by itself. So if it says solve for x, we want to get x by itself. And the way that we do that, we get the variable by itself by using inverse operations. And so what we're going to look at is, sometimes when we start out at 1 or 2 step equations, we can actually go back even further to first, second, third grade, where they had maybe something that said, x plus something equals 10. Okay, instead of an x, maybe they put a 1 here. And so they would be saying 1 plus what equals 10, where now we might have it where it has a variable, 1 plus x equals 10. And so they're really going, what could this be? And they're using inverse operations to say 1 plus something equals 10. We're going to use inverse to subtract. I have a positive here to come up with a value that says, hey, this question, this unknown box is 10 minus 1, which is 9. Or maybe we already came up with 1 plus 9 is what 10 has to be, is what makes it 10. Again, these inverse operations allow us to come up with solving an equation, finding an unknown that makes this a true statement. Maybe we do guess and check. Maybe x is 8. Is 1 plus 8 equal to 10? Doesn't work. X equals 3.14159. Is 1 plus 3.14159 equal to 10? Doesn't work. So as we got older, we went away from just saying guess and check. Is 1 plus 8 equal to 10? No. We move on into something that's more reliable. And that's where those inverse operations come in. For example, our directions here say solve the following equations for x. So if we looked at the first equation, which is 3x equals 15, we want to undo the operation that's in between the 3 and x, because our goal is to get this x all by itself. So if I have multiplication, I'm going to undo that operation with division. There's my division bar. Whatever I do to one side, I have to keep balanced and do to the other side. 3 divided by itself is 1, which leaves me x all by itself. Simplify on this side, 15 divided by 3. That does go evenly, so I don't need to round to the nearest tenth as indicated in my directions. And I get x equals 5. If I wanted to, I can check my work. I can plug back in and say, okay, 3 times replace x, does that equal 15? Well, if we think x is 5, we can replace it here and say, does 3 times 5 equal 15? And by checking it, we know that we've done this correctly. If we didn't get something that matched on both sides, then we would need to go back and check our inverse operations. On number 2, something plus 10 equals 15. And you might already have that answer, but if we keep moving, we want to see if I have addition, what is the inverse operation? Subtraction. So I'm going to subtract 10 from both sides, and when I get 15 minus 10, I'm coming up again with that 5 that we had before. Checking it if I wanted to. 5 plus 10, so I have this kind of unknown, plus 10 equals 15. I believe that's got to be 5 is what I've solved. 5 plus 10 is indeed 15, and I can check my work. It's worth it on a test or a quiz to make sure I check every single one of my answers, because that's how I know how I'm going to be graded. Showing that work, getting the correct answer. If I can check it and know I got the correct answer, I know that I can confidently move on to the next problem. On number 3, now I have something divided by 5 is 14. So something big divided into 5 parts is 14. Well, that means I started with something that, instead of division, was 5 times bigger than 14. I'm undoing this division with multiplication. I still get the 5 over 5, leaving me x. And then on my calculator, I might have to do this one, 14 times 5. And I get 70. So here's my answer. And I can check it. Even with writing it down quickly in my calculator, I can check. Is 70 divided by 5 14? And I can even check it that way without writing something down. As we move into more operations, we're going to do two-step equations where maybe we have to move something and then divide. So we have the order of operations, which is this way. So if I'm evaluating an expression, I would do parentheses, exponents, multiplication and division, and addition and subtraction. If I'm solving, I go backwards. So I check for adding and subtraction and undo that. Then I check for multiplication and division and undo that as I break into exponents and parentheses. So again, right now we're not really looking at exponents or parentheses, but we have this here. So I have subtraction that I need to do an inverse operation for. So I'm going to add 10 to both sides. 7x, I'm going to bring that entire part down and add these two on the other side to get 21. Now I have this multiplication to undo, so I'm going to divide both sides by 7. And 21 divided by 7 is 3. Again, I can check my work, putting in my calculator. 7 times 3 is 21. 21 minus 10 checks out to what I wanted at 11. So when we're doing our order of operations, we go PEMDAS. If we go back, I don't know, what would that be? SAD, MEP, MEEP? If I went the other way, SAD, MEEP? I don't know. I don't think it's really a thing, but it does help us with the order that we should go in here. Let's check number 5. So number 5 we have negative 9 plus 2x equals 17. So again, if I have PEMDAS up here, I'm looking to undo addition and subtraction first. So I need to undo this piece to try to get x by itself. Minus cancels with addition. They add to 0. Negative 9 plus 9 actually adds to 0, leaving me with 2x. 17 plus 9, 26. And once I have that, now I'm undoing my multiplication with division, and I get x equals 13. Check our work, again, by plugging it in, making sure that I get 17 as my correct answer. On number 6, we have division and then we have subtraction here. I'm going to undo that subtraction with addition first. Negative 6 plus 6 is 0, leaving me with x divided by 9. 1 plus 6 is 7. Undo division with multiplication, so I'm going to multiply both sides by 9. I leave with x on this side, and 7 times 9 is 63. 63 divided by 9 is 7. 7 minus 6 equals 1. The checking part should not be complicated or hard or something that maybe your other teachers have made this like big, huge process. It's something that you should be able to do quickly on your calculator and sometimes even in your head using those multiplication facts. All right, on number 7. Okay, I have negative 8 equals 17x plus 9. I'm going to undo the addition. And I'm left with negative 17 equals 17x. Undo the multiplication with division. And I get x equals negative divided by a positive, negative 1. Plug back in, negative 17 plus 9, checks out, gets me that negative 8. On 8, we're moving pretty well here. We have 0 equals 7x plus 32. I'm going to subtract 32 from both sides, where I get 7x equals 0 minus 32 is a negative 32. Undo multiplication with division. 7 divided by itself leaves me 1x. Divided on the other side, and I need my calculator. Negative 32 divided by 7, and it gives me something that says negative 4.571428, blah, 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 blah. All right, so if we look back at our directions, it tells us to round to the nearest tenth. All of our other answers, we have not needed to round. This is our first one where we get this long decimal. So to round to the nearest tenth, I'm going to cut it off at the tenth and look at this number. Because this is 7, I'm going to round this number up. So I'm going to get negative 4.6. So all of this, I'm rounding up into that extra 0.1 here. So when I check my work, 7 times negative 4.6 plus 32, and again, this one I'm plugging into my calculator, I get negative 0.2. That's a rounding thing, but it's close to 0. So it's kind of like, we checked it, but in order for it to be exact, we would need it to be written this way, or okay, we could write it as an exact answer if we changed it to a fraction. So if we change this answer to a fraction, we would leave it as just the negative 32 over 7. This is an exact answer where this is actually, I'm going to use our approximately symbol here. Either one I would be okay with, but right now the directions indicate what they want us to do. So this one is exact, but because we've looked at the directions, this is what they're indicating they want here. All right, we have 2 more here. Okay, so on number 9 here, on our last 2 problems, we have negative 11x plus 17 equals 21. So again, I'm going to undo that addition. So I'm going to subtract to undo it with my inverse operation. And I'm left with negative 11x. 21 minus 17 is 4. Let's try that again, Dale. So we're going to get 4 here. And when I divide that over, so undoing the multiplication here with division, I get x by itself. And then checking on my calculator, I'm going to get 4 divided by negative 11. And I get, again, that decimal negative 0.363636, Rounding to the nearest tenth, as it said in the directions, I'm going to look here at the tenth, and this rounds that up, so I get negative 0.4. On number 10, I have 10 equals 6x minus 50. I'm going to add that 50 over, undoing my subtraction there. So those are adding to 0, negative 50 plus 50. 10 plus 50 adds to 60. Undo multiplication with division on both sides. 6 divides to 1 with 6. And 60 divided by 6 is 10. So again, I can still check my answers. 6 times 10 is 60. 60 minus 5, or I'm sorry, 50, still 10. So check your work, especially when it comes to solving where the equation, you can always go up a step and make sure that every one of those is true. And if you're showing your work, it gives us enough information to find where that mistake was. Because likely it wasn't a big mistake. It might have been a calculator error. I know that I sometimes enter things in, or a mental error like I had here when I almost put 3. So that is 1.1. Let me know if you have any questions, and have a good one.